Hello, managerial finance students. Professor Z here. It's the start of spring break. And what's the first thing that I did once I left campus? I came home to record this video for you to help demonstrate how to calculate a bid price. This is problem 1018. I did sneak a peek though and saw Michigan State get upset. What a upset to get beat in the first round. Totally screws up my bracket. Okay, let's take a look at the problem. This is on page 337 of your textbook, calculating a bid price, problem 1018. Dahlia Enterprises needs someone to supply it with 120,000 cartons of machine screws per year to support its manufacturing needs over the next 5 years, and you've decided to bid on the contract. It will cost you $870,000 to install the equipment necessary to start producing. You'll depreciate this cost straight line to zero over the project's life. You estimate that in 5 years this equipment can be salvaged for $70,000. Your fixed production costs will be $325,000 per year, and your variable production cost should be $10.30 per carton. You also need an initial investment in net working capital of $75,000. If your tax rate is 35% and you require a 12% return on your investment, what bid price should you submit? So what I would do first is go through the problem and highlight the key information that you're going to need to solve the problem. Let me remind you that in your textbook, pages 326 to 327, there's a demonstration on a similar problem that will walk you through the steps needed to calculate bid price. One of the first things that you should do is do some kind of outline or timeline that shows your initial outlays of cash and the cash you're going to recoup at the end. So here's a timeline, and we're going to show that the $870,000 that we spend initially for equipment is going to be spent at year zero. Additionally, we have $75,000 investment in net working capital. So our total initial investment is $945,000. And we know that we will recoup the $75,000 in net working capital at the end of the project. Oftentimes that initial investment is for things like raw materials, inventory. We might have some new accounts receivable. But we will recoup that at the end because all of that raw material and inventory will be converted into finished goods that have been sold, and hopefully all the accounts receivable will be collected. Now the problem also says that we're going to sell that equipment for $70,000 at the end of its useful life. We had depreciated it down to zero, so that $70,000 is going to be subject to tax. So if we take it 70,000 times 1 minus the tax rate, we get 45,500 as after-tax salvage value. So if we add the 75,000 and the 45,500, we've got 120,500 that we're going to receive after taxes in year 5. Now, because we're going to receive that in the future, we need to find out what the present value of it is. I need to change this to 5 years. For 5 years at 12% rate of return. So I would use Excel to find the present value of that 120,500. We just go to financial formulas and we're going to select PV for present value. Our required rate of return is 12%. Number of periods, 5 years. And we are going to receive 120,500 in the future. So the present value of that is $68,374.94. So the present value of that 120,500 that we're going to receive in 5 years, present value in today's dollars would be $68,374.94. So if I look at my initial outflow, initial investment, plus the net present value of what I'm going to recoup at the end, $876,625.06 is the amount of cash flows that I need this sale of this product to cover through 5 years of production. So the question is, what is the annual cash flow amount from sales that I need to cover the $876,625.06 over 5 years? So what I'm trying to solve is, what's the annual sales payment amount that I need to cover present value of those fixed costs. So what I'm going to do is I'm going to use the payment function in Excel. There's payment, rate is 12%, required rate of return, period is 5 years, and the present value that I need to cover is $876,625.06. So that would be a cash flow of $243,184.32 per year from sales. Okay, so now that I know the present value is $243,184.32, I'm going to use the operating cash flow formula. They're found on page 323, and I'm going to use the tax shield amount formula to solve for P, price of the amount per unit that I need to charge to generate enough sales to cover the present value of cash flows needed to cover initial costs. So the formula for the tax shield amount is operating cash flow equals sales minus costs times 1 minus the tax rate plus depreciation times the tax rate. Again, this is on page 323. Another way I could state this is operating cash flow equals the price per unit minus the variable cost per unit times the quantity minus the fixed costs, taking all that times 1 minus the tax rate plus depreciation times tax. So if I insert the numbers that I have so far from the problem and from what I've calculated, I know that my operating cash flow is $243,184.32. I don't know what price I need to charge per unit yet. That's what I'm going to solve for. I do know that my variable costs are $10.30 per unit. That was given to me in the initial problem information. I know that my quantity is 120,000 units per year, and I know that my fixed costs are 325,000 per year. I know that my tax rate is 35%, so 1 minus 35% would give me 65%. And I know that my depreciation is my initial cost of $870,000 divided by 5-year useful life times the tax rate of 35%. So if I solve for that, 870,000 divided by 5 is 174,000 times the tax rate. That means depreciation is going to give me a positive cash flow of $60,900. So now I can just solve this algebraically. That $60,900 that's at the end of the formula, I'm going to subtract that from both sides. So if I subtract $60,900 from $243,184.32, it's going to give me $182,284.32. And then the remainder of the problem, carry that down. Now I'm going to divide both sides by 0.65. I'm going to add 325,000 to both sides, and then I'm going to divide both sides by 120,000 and add $10.30 to each side to solve for P. So when I do that, the $182,284.32 divided by 0.65 gives me $280,437.41. I'm going to add that to the 325,000. That gives me $605,437.41. Divide that by the 120,000. That gives me $5.05 plus the $10.30 in variable cost. Means I need to charge $15.35 per unit as my bid price. So I hope this little screencast is helpful in learning how to do a bid problem.